Alright, let's do the infamous two-sum on lead code. So we're given an integer nums. It's an array of type int, and then we're given a variable called target, and that is of type int, and we're guaranteed that there's only one valid answer, right? And yes, there can be duplicates. So let's do the brute force approach first. The brute force would be to let's look at this problem first. So we have to pick two numbers from the nums array, right? And then we have to iterate through the nums array, pick two numbers such that those two numbers add up to the target, right? So in this case, it's going to be and we're going to have to return the indices, not the actual numbers. So here at index 0, there is this number 2, and at index 1, there is the number 7, right? And then 7 plus 2 is 9. And let's look at this one. So index 0 and index 1. This is index 0 and this is index 1. 3 plus 3 is going to give us a 6, right? So let's do the brute force approach. So our task is to pick two numbers, right? So we're going to go, a plus b equals target. And using simple algebra, we can do something like a equals target minus b, or b equals target minus a, right? Same thing. So let's do for int I equals 0, I less than nums dot length, I plus plus, for int I j equals 0, j less than nums dot length, j plus plus, int a equals nums I, and then we are looking for int b, right? So we're going to iterate through, so int b is going to be, okay, let's uncomment this. Int b is going to be target minus a. So we're going to iterate, so we're actually going to do this here, and then we're going to iterate through the whole array again, and then look for this, right? And another thing to keep in mind is it can't be so like j is going to start at 0 and it's going to come again to I, right? So when it does that, when j equals I, like we're just picking the same number again, and we can't do that. So when this is the case, we have to skip. So if j equals I, continue, and then if nums j equals b, return new int I and then j, right? And then by default, I mean, this is never going to happen, but since we have to provide a default return value, we're just going to do something like this, right? So let's zoom out and then run this. if you look at the time complexity, it's going to be O of n square, because clearly we are using two for loops. It's a nested for loop, right? So it's O of n square. Can we do better? Yes, we can. Let's look at the constraints real quick. Let's look at the problem actually. So what we're doing here is basically this whole thing right here. We're basically checking if something exists in an array, right? Yes. So what do we know about lookups? We can use something like a direct index or a hash map if you want to look something up in O of one time. And are we sacrificing space for this O of one lookup? Yes, we are. So let's try to implement a direct indexing here. Let's look at the constraints before we do that. Okay, from the constraints we can see that it can go to negative numbers. Like it can reach, like this can be a negative number, and it goes up to 10 to the power of 9. So which is a really, it's not a good, it's not like, if we do direct indexing here, a lot of space is going to go to waste, and we're going to have to allocate a lot of space. So we're going to go ahead with hash map. And the reason we're using a hash map instead of a hash set is because we're returning indices and not the actual numbers. So that's the main reason we need a hash map. Hash map integer map equals new hash map. Okay, so let's talk about what would happen if there were duplicates, right? Let's look at this example. So we know that like the hash map is going to look like this. It's going to have a key of type integer. So let's say and the key is going to be nums I, and then the value is going to be I, right? And then so we're going to iterate through this array, right? This is case number 3 from the question, this one. So as we iterate through the array, we're going to encounter this one, right? It's going to be a 3, and then this is going to be let's write down the indices too. So this is index 0 and this is index 1. So this is going to be 0. And then what's going to happen now is we're not going to create a new key. It's not going to create a new key. It's just going to get this one, and then it's going to update the index to a 1. It is going to overwrite the index, and that's okay, because even if we do that, like, okay, let's say like it's 0, right? Like if we come to this index, we're still gonna look for the 3, and there is gonna be a 3 at index 0. And let's say if it was this one and we were at here, right? So we're still gonna look for 3, and then it's gonna be at index 1. So it's not like we're messing up the algorithm or anything. So let's create the hash map. Equals 0, less than nums dot length I plus plus, map dot put nums I, map, okay, or I can just do I, right? And then we're gonna do a second iteration, int I equals 0, I less than nums dot length, I plus plus. So int what we have is nums I. What we need is target minus nums I, and we're gonna look for it in the end. We're gonna look for it in the hash map. So if map dot contains key need. And remember, when we were doing the brute force, we were making sure I wasn't equal to j. So here, similarly, we had to do the same thing. So we had to do map.get need is not equal to I. Only then we're going to do return. The have is we got it using this index right here, and then the need index is we can get it by doing this return new and I, and then map.get need. Remember, we stored the indices in the hash map, right? So the key was the nums I, and then the value was nums j, or sorry, I, right? So, and let's run this. Hold on. Oops, I forgot to do that. Yeah, so this time complexity is going to be O of n, right? So, and then we just sacrificed some space for a better time complexity. So those are the two solutions for this problem.